Okay, negative exponents are on the agenda for today. When you get done with your notes, make sure you tape them into your notebook neatly using pages 99 and 100. Alright, integer exponents. When an exponent is a negative number, we can think of it as taking the reciprocal. The reciprocal that you probably learned about in 7th grade was if you had a number like 1/3, the reciprocal would be flipping it over. It would be 3/1. So we're kind of taking reciprocals when we work with negative exponents. You'll know to take the reciprocal when you do see a negative value. So basically this is what it's going to look like. You're going to get a number to some negative exponent. So let's use the idea of 5 to the -3rd power. What it turns into when you rewrite this as a reciprocal is you're going to put 1 in the numerator. You're going to put your 5 in the denominator, but instead of having a -3 exponent, you're going to have a positive exponent. This positive exponent is going to allow you to evaluate the question. You know that 5 to the 3rd power represents 5 times 5 times 5, which is 125. So one way to talk about the value of 5 to the -3rd power is to just use 1/125. Sometimes we don't want to use a big fraction like this, so that's why we have negative exponents in case we want to use negative exponents. We don't typically like to leave our answers as negative exponents, so that's why you need to know this little rule about using the reciprocal when there's a negative exponent to rewrite the base to the positive exponent down at the bottom of the fraction. So on your note sheet we have a couple practice problems to do together. When you have a base of 4 raised to the -2 power, what we do is we use the exponent, or we use the reciprocal, and we put 1 over. We're going to leave the base 4, but we're going to make a positive exponent. If we wanted to evaluate further, we could figure out 4 squared is really 16, and this would turn into 1/16. We're going to practice the actual evaluating down here where we work on the value. Up here, we're just going to rewrite using that positive exponent. So question 2, we have h to the -6 power. You're going to use the reciprocal. You're going to put that h down at the bottom of the fraction, but you're going to use a positive 6 instead. Number 3, you have 11 to the -7, so it's going to become a reciprocal 1 over. You got your base of 11, but this time it's a positive 7 exponent. And for number 4, n to the -3 becomes 1 over n to the positive 3 power. So again, this is just using our rule that allows us to work with negative exponents and fractions. Down at the bottom of your note page, when you evaluate, you're actually trying to find the value. So if we do end up with some exponents, we're going to actually calculate and get the value of that number. For the first one, we just end up with 1/8 to the 1st power. 8 to the 1st power is still 8, so that's why we just have 1/8. For this one, we're going to end up with 1/10 to the 4th power. So here's where you can actually use your calculator. You can figure out what 10 to the 4th power equals, and it does equal 10,000. So that's why the final answer for this one becomes 1/10,000. For number 7, you're going to rewrite it using the exponent, or the reciprocal, 1/7, and you're going to make sure your exponent is now positive when you rewrite it. We know that 7 squared really means 7 times 7, so that's where this 49 comes from. And for the last example on the front, we have to rewrite it using the reciprocal, 1/2 to the positive 3 power. 2 to the positive 3 power, remember, means that we're taking 2 times itself times itself. So that's where the 8 is going to come from in this last example on the front. Now, for the back of your notes, we're going to focus on these first two. Using the laws of exponents that we talked about earlier in this unit, we know that raising a power to a power is going to generate a multiplication problem where you'll leave the base of 6, but you'll multiply your exponents to give you a -6. Now, using what we learned today about negative exponents, you're going to put 1/6, and you're going to change your exponent to a positive 6. Now, for number 10, it can be a little confusing because up here you have a negative exponent. You're subtracting because of the division between the two bases. Negative 4 minus 3 is actually going to give you 5 to the negative 7 power. Negative 4, take away 3 more is negative 7. So in this case, you're going to end up with 1 over 5, but then it'll be a positive 7 power. And again, we started out simplifying using our rule that we learned the other day. You can subtract exponents of bases that there's a division problem around. And then again, with number 9, you can multiply exponents when you have a power raised to a power. Those are some of the exponent rules we had worked with. For number 11, we're practicing the exponent rule that says if you have your bases that are the same and you're multiplying, you actually can add your exponents together. So if we add 1 to negative 6, we end up with negative 5 for our exponent. And again, when you have a negative 5 exponent, you're going to use the reciprocal. You're going to put 1 over the a, and you'll have a positive 5 exponent at that point. This one simplifies kind of all by itself right away, because power to a power we know we're going to multiply. A negative times a negative turns out positive. So for this one, there really isn't any simplifying to do, although there must be a typo on this one. This one does not end up with c to the 21st on the bottom of the fraction. They both look like negative numbers to me, and negative times a negative would be a positive 21. This one takes a little bit of simplifying up front. You can work on the product rule here, which says if we have like bases and you're multiplying them together, you can add your exponents. When you end up with the same base with 3 to the 3rd, 3 to the 5th, we are going to simplify using our subtraction. 3 minus 5 gives us negative 2. So now, if you have a negative exponent, you can practice the rule we worked on today. This one does come out to be 1 over 3 squared. This one's going to take 2 steps to simplify it. We're going to first simplify by subtracting. I believe that's a negative 8, so if we do 4 minus negative 8, we're actually generating 4 to the 12th power. And then next to it, we have 4 to the negative 14th. The product rule says that we're going to go ahead and add these exponents together, keeping the base the same. When you add positive 12 to negative 14, you're generating negative 2. And this should give us 1 over 4 squared when we rewrite using our reciprocal of the base to the positive exponent. Now what I'd like you to do is take the second little notes page, and I'd like you to go down through what we learned today with the negative exponents and simplify and evaluate these 4. Then I would like you to review using the properties of exponents that we learned about yesterday. See if you can simplify these. Pause the video and then play it once you're set so you can check your answers and get your book, your notes taped into your book. Okay, for this first one, we're just practicing that reciprocal rule we just learned, 1 over 6 cubed. 6 cubed is where the 216 comes from. 18 to the negative 1 power, you do your reciprocal. We could put our little 1 up here, but we don't have to because we know 18 to the first power is still 18. Down here, we would do this the same way, even though we have letters for our bases. So this one's just going to turn into 1 over 2 cubed, 1 over g to the 8th. Now at the bottom, you're practicing to see if you remember that one exponent rule. We said anything to the 0 power is 1. A number to the first power is 93. This one is based on the fact that we have 16 squared, which means there's 2 factors, next to 16 to the 3rd, which means there's 3. If they all get combined together, that's how we end up with 16 to the 5th. Here's x to the 3rd in red, x to the 5th in green, all together x to the 8th. So basically you're adding exponents to practice here. For this section, you could just subtract exponents. 4 minus 1 gives you the 3, 6 minus 4 gives you the 2. I wrote out all the factors showing you the canceling. It makes it easier to see that you have 3 left over here and 2 left over here if you want to show your factors. And for the very bottom, this is how you would work with power to a power. The shortcut rule is to multiply the exponents together, and that would give you your 4 to the 6. If you want to see what this really means, because 4 cubed is being squared, it means we have one of these things times itself. And then this represents that we have 3 of them in a row next to 3 more, which is where the total of 6 comes from. P to the 5th to the 3rd power, again, we could just multiply power to a power to get our 15, or we could write out what we actually see. We have 3 groups of p to the 5 power that we have to multiply together. This means if we wanted to write it out, we'd have 5 of them here, we'd have another 5 in the middle, and we'd have another 5 at the end. So 5, 10, 15 is how many we would end up with. Now that you're set with your note sheet, make sure they get taped into your notebook neatly. You've got to have page numbers, you've got to have titles. You want to make sure this opens up so you can see both sides of your note sheet, and you want to make sure you have all correct answers to use as a resource in the future.